a rectangle. This is a very important expression that we are going to be looking at today, where candidates or students following should take note, where n is an integer that starts from 0 and accumulates through 1, 2, 3, depending on the number of iterations that we shall be taking. Xn plus 1, which is a better approximation of this root, is equivalent to the first root minus the function to that first approximation over the derivative. F prime of xn means that we differentiate to first principles. I am still on the introduction, so please take note. I am still on the introduction, and your focus should still be here. Your focus should still be here. We want to see how do we prove this expression. How do we prove this expression? We are going to consider graph. We are going to consider graph of the function y is equal to f of x. And if this graph is sketched as we discussed previously, the root is that value here. The root is that value here. This is the root to the equation or to the function. And this is our function y is equal to f of x. Now, this expression or this graph is a graph of y to x because the function varies as x changes. We shall consider a tangent at a point here. If I consider this as a tangent and I take the point of interest to be here, I can extrapolate this to take my tangent here, and I will consider this coordinate to have at xn, which is the first approximation, the function corresponding will be this. And therefore, this, if I call this point A, it has coordinates of xn f to the xn. I want you to pay attention to this sketch. I've already indicated where the root lies. And the next approximation would be considered to be at a point where this tangent cuts the x-axis. And we shall call this xn plus 1. But the coordinate at this point, since when this curve cuts the x-axis, the value of y will be 0. The corresponding coordinate, if I call it b, the coordinates of b will be xn plus 1, 0. That would be the coordinate corresponding to this point b. Therefore, we want to find out the proof to this formula here. How do you prove it, supposing they asked you to prove it? This is the origin. We have our function, and our interest is to find the gradient at this point A. So to find gradient at point A, we all know that gradient is going to be change in y, which is this, over change in x. Change in y over change in x. And gradient, note that gradient, if I may call it m, as most of you should be aware that m is a symbol for gradient, in this case will be the first derivative of that function. So along AB, my gradient, which is supposed to be equivalent to this, is going to be between points A and B. Point A is already given over here as xn f of xn. And of course, we have our xn plus 1, 0. So the change in the f function would be f of xn minus this minus 0 over xn minus xn plus 1. That is our gradient, and we are going to work through this expression to make xn plus 1 the subject. If we cross multiply, we shall have f prime xn into xn minus xn plus 1 being equal to our fxn. I want us to be systematic. We are looking for the gradient of AB, and the gradient is going to be change in y over change in x. The coordinate here, which I have put over there, is xn plus 1, 0. xn plus 1, 0. And when we substitute in, our change in y will be fxn minus 0 over xn minus xn plus 1. If we progress steadily, with that function, we shall get that xn, I'm opening brackets here, into f prime of xn minus xn plus 1 into, if we open there, into f prime xn should be equal to our f xn. Since my interest is this one, I am going to take this the other side, and that means that when I take it the other side, I will have my f into xn plus my xn plus 1 into f prime of xn should be equal to xn into f prime of xn. I want this only, so I'll take this the other side. So my xn f prime of xn, leaving it here, that is xn plus 1, should be equal to my xn f prime of xn, which is already there, minus f of xn, which I'm picking from here to that side. And now I will divide by f prime xn throughout. If I divide it on the left and on the right, I will get xn plus 1 into f prime xn over f prime xn should be equal to xn f prime xn over, let me separate it straight away, minus fxn over f prime xn. Clearly, this will cancel out, and that will cancel out, and our xn, as earlier obtained, the better approximation to the first approximation is given as xn minus the function itself to the first approximation over the first derivative of xn. And this is the expression we got, or we stated at the very start, which I emphasized and I will still emphasize will be very, very helpful in our further discussions effective to date. This is a proof of that approximate route to the first approximation. I therefore want to conclude, but I will give an opportunity for students 1 minute or 2 to first capture what is right over there before I conclude, and then we look at some examples while using this information. The function f of x has an approximation that we said is the first approximation, and that approximation was xn. And we have said that xn plus 1 is a better approximation of the first approximation. As we come to the conclusion of the introduction and use that information to look at application questions, my dear students out there, I want to remind you that if we consider variation of n and we look at n as 0, then we shall get the first approximation. If n is 0, our x n plus 1, if n is 0, our x n plus 1 now becomes x 0 plus 1, which we shall write as x1. And x1 will therefore give us x0 minus f of x0 over the first derivative of x0. This will be the first root. The successive root, as we try, depending on the number of iterations, when n is now 1, we are feeding in there, we shall get x as 1 plus 1. So this gives us indeed the second approximation, which is supposed to give us now, as you notice, n is 1, so it is x1 minus f into x1 over the derivative of fx1. If they want the third trial, our n becomes 2 and the pattern increases. This implies that we get x2 plus 1, which becomes x3. And that means that as we look for the value of x3, we feed in the previous root, x2. It will give us now our f of x is 2, minus f of x2 over the derivative of x2. This pattern can go on and on, depending on the number of iterations we are expected to try out. However, what I want to emphasize here is that the formula is successive. We use it successively, get the first root, apply it into the next time, depending on the conditions of the question. And the magnitude of the difference between the first and the next root, which I will emphasize, that candidates here should note that if I get x n plus 1 and I take away x n, whether the value I get is negative, that's why I put the modulus sign. It is going to be considered as positive. It is expected to be less or equal to the error, less or equal to the error, or otherwise what we call the tolerance, T-O-L, otherwise what we call the tolerance. And depending on the number, for example, I can say, if, for example, x naught is 0.2, this I want you to understand. If it is 0.2, it means that the error in this root, if this is the first approximation, the error here, where there is a 2, usually put a 0 and then put a 5. That means that the error here will be 0, will be to 2 decimal places. If they tell us to find the root approximate, this is 1 decimal place. approximate to 2 decimal places, then assuming that my first trial is negative 0.32, even if it is 0.3, but they have said now 2 decimal places, it implies that the error margin we are looking at for 2 decimal places, you'll put 2 zeros, so 0.005. So this will be the error we are looking at, that the difference between 2 consecutive roots or successive roots should be less than this error if you are to consider that you have now converged to the correct root of the given function. And that is extremely very important. Sometimes they give the number of iterations. They say, using only 3 iterations, find the root. That means we shall take the first approximation, the second, the first one, the second one, and the third, and the value we get there should be considered to be the root of the function. So I can say, note number 2, that successive iterations to the root or approximations to the root, that is, we start with 0, x0, x1, x2, x3, and so on. Those successive iterations must converge. Must converge for the root to exist. If you still remember what we shared in our last lesson, the statement that must converge means that every time we are getting the root, the first approximation should be decreasing towards the root. Should be decreasing towards the root that is required. The other emphasis I must mention here is that the derivative of the function, which we are calling f prime x, must be seen in any candidate's working. The derivative f prime of x must be seen. That's the first derivative, which we feed in here in our general formula. With that introduction, I want to now ask you to focus on the question that is being displayed for you to see. There is a question there which we are going to take as our first example. There is a question there which we are going to take on as our first example. And the first part of that question is a very simple requirement that I am sure all of you are able to do. So allow me, as you capture that question, to clear my workspace over here. And as usual, I will not forget to remind you that if you can't write very fast to capture that question, you can as well take a picture of that question, study with the teacher, and later at the end, you compile your work by fitting in your book the question at hand. You are also expected to have your calculators nearby. Example number 1. Since you have the question, I will simply interpret what they want in form of giving the solution, and then we progress. I will say that my function now is that expression which is x cubed minus 6x squared plus 9x plus 2. This is my function. The first question says, that we show that this equation has a root between, the root lies between -1 and 0. They want us to show that the root lies between this, and all of you are aware that if the root lies in between there, then the product of the two expressions, f of 1, our f of x, we shall feed in -1, and we feed it here. -1 cubed minus 6 into -1 squared. I am substituting plus 9 into -1 plus 2. F of -1, if we compute, will give us negative. A negative to a power that is odd stays negative. It is -1 times -1 times -1. So we shall get -1 here. A negative squared. This is where candidates may make a mistake here, because this is negative, they may think it is positive. But this becomes positive, and it still ends up giving us -6. And here we have -9, then we have 2. If we accumulate, we have -10, -16 plus 2, so we shall get -14. When we try the 0, for x as 0, this was for x as 1, -1. For x as 0, our f of 0, all these terms will die out, but I can put them there for purposes of consistency. Any number times 0, all of you know that it is going to give you 0. Summarily, if this is x and this is f of x, in a summary, I can use you in a table and say for x as -1, I got -14, and for x as 0, I have got +2. And I can say that since f of -1 times f of 0 is less than 0, then the root lies between the -1 and 0. Then there is a root confirmed to lie between -1 and 0, because the product, which is -28, is less than 0. The product, which is -28, is less than 0. I hope that first part is well understood. However, it is also possible for the candidate to say that this is conclusion number 2. If you don't want to conclude like that, you can say that since there is a change in sign, since there is a change in sign, since there is a change in sign between the two expressions, then the root lies between, like I stated here. There is a root that lies between -1 and the root itself and 0. That means the root must be greater than -1, but it should be less than 0. And we shall go ahead to look at that. For part B, they are saying, show that the Newton-Raphson formula for approximating the root of the equation is given by that expression. So for part B, we already have a function, but I will repeat it. That our f of x, and this time this is f of x, is x cubed minus 6x squared plus 9x plus 2. I told you it is very important for us to ensure that the derivative of this function is used. So if we differentiate this, I have not introduced the xn, then this will give us 3x squared. 3 times x, and we reduce the power by 1, minus 12x plus 9. If we introduce the first approximation, which is xn, then we can say that it implies, therefore, that f to the xn will be, we put xn on each, xn cubed minus 6xn squared plus 9xn plus 2. And since we already have these, we are simply putting the first approximation. After getting the first derivative, this will be 3xn squared minus 12xn plus 9. To show that the first, the Newton-Raphson formula for approximating the root is given by that expression, we are going to quote the formula. And we say that using that xn plus 1 is equal to xn minus f of xn over the derivative of xn, we shall now substitute in for these functions in this expression. And our xn plus 1, therefore, will become xn minus, my function is xn cubed minus 6xn squared plus 9xn plus 2. I will put brackets all over 3xn squared minus 12xn plus 9. Now this calls for carefulness of the candidates. It is now algebra, and we need to do the mathematics. This is over 1, so we are going to take a common LCM, and I will put my next step here before I shift to another page. That my xn, if I take this as a common LCM, it will stay down here as xn squared minus 12xn plus 9. If I divide the whole of this by 1, it will stay, but I already have my xn here, remember? So it will be into this squared minus 12xn plus 9, close brackets, minus. If we divide this there, it goes in once. So it will not affect this, but we are going to open this bracket. When we open the bracket, we shall have this giving us xn squared cubed plus, because this is minus minus, and this is 6xn squared, minus times the positive will become a minus 9xn, then minus 2. Then minus 2. We are going to clear this first part where we answered part A as we move towards the conclusion of this first proof. We are supposed to show that this simplifies that root. What happens? I am going to open brackets in the first case, and then we simplify. My xn plus 1, I still have my denominator of 3x squared minus 12xn plus 9. But now I want to open this, and it is a long expression. It's a long expression that is going to be squeezed to fit in there. I will have xn times 3xn will give me 3xn cubed, because this is squared, minus 12xn squared. plus 9xn. I've finished opening this bracket, so I'm going to take away what is there the way it is, minus xn cubed plus, because we already subjected this there, plus 6xn minus 9, this is squared, 9xn and minus 2. If we look at this term will cancel with that term. I usually do not advise cancelling as mean, but for purposes of this number, we can cross out what cancels. 3xn cubed minus xn cubed will give us 2xn cubed. 12xn is a negative, plus this will leave us with 6xn squared, because this half will cancel with half. And then what else? We have minus 2. Our numerator should be beginning to look like the numerator of the final expression. And you are encouraged to keep carrying the left-hand side. 3xn squared minus 12xn plus 9. The numerator has a common factor of 2, and the denominator has a common factor of 3. If I pull them out, I should be able to get my final expression as indicated. This will stay as xn cubed minus 3 xn squared minus 1 all over x, there is an xn here, xn squared minus 4 xn plus 3 as required. This should be as required. So at that stage, the candidate will have successfully shown that the formula to the first approximation is actually given by this expression here, over here. This expression has now been fully obtained as required by the examiner. It is important that candidates attending this lesson take note of that work. Simple, consistent mathematical skills are definitely expected from the candidate pursuing or offering this very principal subject. No wonder that as I share, or I have always shared, people that do mathematics beyond A level normally work in areas where there is a lot of consistency, effectiveness, and strict computations and order. That the mathematics tunes you to be orderly, organized, focused, and consistent, and of course efficient. We have finished going through successfully B part 1, and we are set to proceed and look at part 2. We are set to proceed and look at part 2, and I want to challenge you to look at part 2. Part 2 will be rubbing off shortly, but part 2 says use the formula in B1, which is this formula we have just got. Use the formula in B1 above. With the first approximation, they have given us the first approximation as negative 0.5 to find the root of the equation correct to 2 decimal places. Now that 2 decimal places communicates about the TOL, what we call the tolerance or the error. If they want it to 2 decimal places, then the error will be 3 decimal places. I will be rubbing off starting from there, and I will request that you allow me clear this space so that we can look at the last part of this number. We can look at the last part of this number. The last part, they are giving us that our first approximation, which we called x naught, is negative 0.5. And that means that our error, because they are talking about 2 decimal places, is 0.005. Since they have not told us that using 3 iterations or trying it out 3 times, find the root, we are going to try it until when the error between the 2 successive roots we shall be getting is less than 0.005. That's what it means. And using our expression of xn plus 1, which we still have, I'm not going to rewrite it. My first approximation, which is x1, that is, I'll say for n equaling to 0, my x0 plus 1 will give me my x1, which we want to get. So our x1 is obtained by feeding in this, and I will say it is 2 out of 3 into negative 0.5, this is cubed, minus 3 into negative 0.5, this is squared, minus 1, everything over our negative 0.5, this is squared, minus 4 into negative 0.5 plus 3. I will request candidates out there to compute this directly, because I am not going to compute and show you the next step, but allow me to say when you compute, this will give you a value which is negative 0. Since they want 2 decimal places, we shall be writing our values to 3 decimal places, so that finally, when we get the convergence, we write our answer. After getting this, we will need to find the convergence. x1 minus x0 modulus will give us negative 0.238 minus our x0, which is minus 0.5 modulus. And when we subtract this, it will give us a value of 0.26. This is greater than 0.005. This therefore notifies us that this is not the final approximate root. It is not, since it is greater. So we feed in now this as our x1, using x1 as negative 0.238. We look for x2, our second approximation. Our x2 will become, we repeat, 2 out of 3 into negative 0.238. We cube it, minus 3 into negative 0.238. We square it and take away 1. All over, we repeat, negative 0.238. This is squared, minus 4 into negative 0.238, then plus 3. Again, when you compute this, it should be able to give you a value which will again prompt you to check the tolerance. Negative 0.197 is what we get upon computing. Check the tolerance to see. This is a very good example to start with. And it puts you at a position where you get the content very well. Negative 0.197 minus 0.238 modulus will give us a value when you compute of 0 point, because this will change into a positive 0.141, which is still greater than 0.005. So that confirms again that negative 0.197, much as it is less than 1 negative and also less than 0, it is not yet converging to the root we want. We try out the third time and we look for x3. Our x3 implies that we use x2 as the value, so it will be 2 out of 3 into negative 0.197, this is cubed, minus 3 into negative 0.197, this is squared, minus 1, all over negative 0.197, this is squared, minus 4 into negative 0.197 plus 3. This is the consistency I was talking about. That if you are not consistent and you feed in wrongly or you compute wrongly using your calculator, you can be sure you are going to get a wrong value. And as a candidate or a student, allow me to mention this from experience, that when you get a wrong value, it is very hard for you to tell that it is wrong, because even when you try out the second time, because it is still the same head trying out, or the same person, most likely you will still get the same value, which is wrong. And you may convince yourself that you're actually getting the right value. So be consistent. If we check for convergence, a convergence is going to bring me over here to see, is this number converging yet? If it is not, we continue, because we were not limited to the number of trials or iterations. Convergence x3 minus x2 now will give me my negative 0.196 minus 0.197. If we look for the difference here, we are getting a value this time round that is clearly 0.0001, which is now less than the error. It's now much smaller than the error, and we can conclude therefore that the root of x, the root of the expression of the function f of x, which we all know is x being equal to negative 0.196. But remember, they said to 2 decimal places. So to 2 dp's, we conclude that our x is approximately 0.202 dp's. We obtain our answer right over there as that. We obtain our answer over there as that. I will, yes, ask the producer, as he has already done it, to prepare us for the next number. And I also want to prepare you that our interest is not finishing the next number, but our interest is understanding what we are being taught. Usually I tell students that it is not how much you read that matters, but how much you read and understand. It is not how much you read that matters at any one time, but how much of what you read and understand. So it is not about the time we spend learning that matters, but it is how much do we understand in that particular lesson. Number 2 is right over there. And we have several examples, and each example is very different from the other. We shall attempt to start on the first, on this number. And should we fail to finish it, I am very sure, I can assure you, that I am very sure if you have understood the first number, where we shall leave this number will finish correctly. The advantage is here they are giving us, it's a proof. Assuming that my followers have already captured this, we can clear off this. If you haven't, please note it is very important for you to have this first example well understood, especially if a number requires such iterations. 3 trials before we converge, we get the root converging. And it should not demoralize you. This is a very common number, and whenever it comes, extremely very easy. However, it pre-assumes that the candidate must have the knowledge of differentiation, whether of trig functions like this second number now. Number 2, we shall let the function, let our equation be in the form of f of x is equal to 0. We put that equation in the form of f of x is equal to 0. This implies that from 2x being equal to the cosine of 2x, we will express it by taking 1 the other side. It implies we shall say this is 2x minus the cos of 2x is equal to 0. So our f of x is 2x minus the cos of 2x. Our derivative will give us 2 if we differentiate a cos that has this part. It will become a sine. But usually, d by dx of cos of x is minus sine of x. So it is going to become a positive. I will simply tell you what happens. This we differentiate this first, and we get a 2. Then we differentiate this, which will be minus sine of 2x. I will say, note for those that have not done differentiation, that if we differentiate cos of 2x, we get minus 2, we get minus 2 sine of 2x. So it is this minus times this minus that makes this positive. And now if we state the formula, we shall first of all write our xn is going to be 2xn minus the cos of 2xn. And our first derivative expressed in terms of the first approximation will be 2 plus 2, the sine of 2xn. If I substitute in our xn, we must first get the expression for xn plus 1 for us to be able to do this number. So using xn plus 1 is equal to xn minus f of xn over f prime of xn, we can get this expression as xn we substitute in minus 2xn minus the cos of 2xn, the brackets should not be forgotten, over 2 plus 2, the sine of 2xn. I will say that by taking the LCM, the candidates should be able to get, I'll take it straight away, to get our xn plus 1 being equal to, I'll do it straight away, xn into 2 plus 2, the sine of 2xn, minus, allow me open this, 2xn plus the cos of 2xn. The whole of this is now over a common LCM. What follows is opening brackets. We have 2xn plus 2xn, the sine of 2xn, minus 2xn, plus, because I already removed the decimal place, the brackets, that this is over our 2 plus 2, the sine of 2xn. If you look at this, this term will cancel, and when it cancels, we shall finally stay with the expression which I can write here as we wind up our lesson, that our xn plus 1 will become 2xn, the sine of 2xn, plus the cos of 2xn, all over 2 plus 2, the sine of 2xn. If we factor out that 2 down, we shall wind up with that. We can leave it here. So I want to challenge the candidates to continue and finish this. If our first approximation is pi out of 4, you are supposed to get your first approximate root by substituting in this. Substituting the x naught as pi out of 4, but take note of radians. Take note of radians. Even if you didn't take note of radians, you could use pi as 180. You will be able to get the first approximation actually direct away as that root. I want to thank you for following this lesson. I want to encourage you to continue checking and subscribing on my YouTube channel, Teacher Kakuru. And I want to ask you to continue following programs of BBS TV. God bless you. Gachali Mabaga. Keep working.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisa
Oh yeah, Raphson is my friend. I don't need to worry for the rest of my day. Hakuna Matata, voice and data bundles. Free OTT. Now I got social distance. Call you all day. Hakuna Matata.
Hakuna Matata, the newest bundle from Raphson. Lots of data, unlimited calls, and free OTT. Dial star 133 hash. Select your preferred daily, weekly, or monthly bundle, and Hakuna Matata. Stay connected, stay safe. Raphson is regulated by Ghana Communications Commission.
Hakuna Matata.
Owange gyebaliku okuteka ku ssente leero munyoluka mmotoka yo olinnya lifuti oba okute ku mapesa ga kompyuta yo ku mulimu olinago okuteka mu ngalo oba ku ssimu yo yennyini weetaaga skin guard hand wash soap ne sanitizer linda ku katono tunuuya engalo zo oziraba oyinza okuba okutte ku kintu ekiriko obuwuka bwa coronavirus kubanga busobola okwekwekako okumala essaawa nnyingi nnyo kati nno wulira amawulire amalungi weetaaga skin guard hand wash soap ne sanitizer mu mikono gyo mu bibatu wakati w'engalo ne mu njala zo weekuume ne Skin Guard. Skin Guard is a brand of Mobit Products Limited.
Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweeweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab. Abasomesa baffe abatendeke mu kusomesa n'okubangula abayizi kuno nga twongerako n'okukulembeza ebitone. Kati nno ggwe omuzadde omwana wo mulete mu kifo kimu kyokka ekigenda okumuyamba okwongera okunnyikiza ebyo by'asoma era ng'essomero liri limu lyokka ye Maryland High School erisangibwa Entebbe. N'okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
okwewala oba okwekuuma akawuka ka covid-19 akalumya ensi yonna. Bino wammanga byolina okukola okuziyiza okusaasaana kw'akawuka kano aka covid-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola obanyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibin yo. Bw'ofuna obubonero obulaga covid-19 sigala ewaka okubire aba Ministry of Health ku 0800-000-666 oba ku 0800-2030-33 okufuna obuyambi. Wabula bw'oba oyagala kuzza bujja intaneti yo eya Rock Telecom, kozesa emikutu gyaffe egya digito nga Mastercard, Visa ne ba agent. Osobola okunyiga *252#, sigala ewaka, sigala nga weekuumye, sigala ku Rock Internet.
Rock Telecom. BBS, terefayina eyaffe.
Roundabout ewagidwa.
Jayo oba teekayo sente ku account yo ng'okozesa Center Agent oba ATM zaffe. Nyumira enkola ya banking ekulaakulanyiziddwa bw'oggulawo Center Express account ofunirewo commission era account eno tegibwako bisale ebya buli mwezi. Enkola eno yakukwanguyiriza mu mpeereza zaffe.
Centenary Bank.
Wamune.
Kayibanda sente nga mwezi. Sente zona bali zitutanene bandekera mukama nayamba.
Mukama nayamba drink alimu ekyama ate nga yatongozebwa ba UNBS.
Mukama nayamba bwe bulamu bwange.
Wamune.
Poza daipa ngomu bulungi ate nga tezikwasa mwana bbugumu. Poza daipa eyisa bulungi empewo mpeweevu ziwa omwana emirembe nungi ku lususu tezibutula ate nga tezivaamu kisu. Zisanga mu kibangizi ky'abannamakolerero gogo ku Nick Building oba tukubire ku 0786-066-268. Poza Diapers emirembe gy'omwana wo.
Kale buterevu nnyo ennaku z'omwezi ziri 3 omwezi ogwa tuyingidde July August,
yes.
Omwezi ogwa August eguba gwa the 8th month of the month, 8th
of the year,
of the month of the year.
Tugenderawo kirabika.
Okay. Kale twagala okubaaniriza twagala okubaaniriza mu mwezi omujja era tugabaagaliza omwezi omujja ogw'emirembe. Ekyennaku ekiriwo nti abantu bakyakkiriza nti omwaka gugenze naye people have begun rebuilding themselves okuva mu COVID. So whatever you do lekera okwekubagiza munnanga alaba programu eno tutandika okubanga tweddabuluza. Do you get what I'm saying? So yeah, you will still have some months omwaka guleme kugenderaawo.
Tegunnagenda nnyo abamu May 2020 ya.
Eri ababivuddeko edda amaanyi kati guno gugenze kambiveeko buli kye bakola tebakyakiteekamu maanyi. But I'm sure bwoguwa wewe omukisa noweddabuluza ate tojja bonaabona nnyo.
Nokyusa mu bye wakolamu obubi.
Yes sir. Kale amanya bampita mu Goodwa Jonah Jackster kansala w'abantu to be enakawaawo era nga ndi ne Tash Byebe. How are you, Tash Byebe?
Nange bampita Byebe nendi Byebe wa Jackster mu studio. Actually we love you so much. Buli muntu abeera ku BBS Terefayina ng'olaba program roundabout ne programs ez'enjawulo amannya go bagambye tugenderaawo. Teweerabira ntate mukwano abamukama nayamba bakuleeterako okunywa akagula emisuwa kana okunywa kaliso organic and natural nti woba olina ne kihangover n'okozesa mukama nayamba ekintu kiba kitambula bulungi. Omukyala ng'obulamu bukugendera bubi okurampinga bikuluma si kyekyo kyokka emigongo gibaluma kwegamba mukaddiye mukyali bato kozesa mukama nayamba kubanga lino lino ddagala ate nga kyakunywa ekiriko ennaku zino.
Engeri gye mulimu omulondo. Mwe mukittani.
Era gw'oyagala okwogerako.
Engeri gye mulimu omulondo.
Abasaada.
Abasaada.
You know what we mean?
Yaman.
Okay.
Ivan K.
Ate nga Centenary Bank bakujjukiza mukwano nti bano osobola okugulawo Sente Express Savings Account n'ogigulirawo ab'ekika kyo, mikwano gyo, mwana wo. Ate nga buli muntu gw'obagulirawo account eno Jackster bakuwa ka commission akatono kw'oba otandikira. Towerabira nti ate olina okubeera ng'olina Sente mobile app mu simu yo eya Centenary Bank okugulawo zino account. Osobola okugulirawo omulala ate ng'okozesa Sente Agent n'okukozesa gundi ATM card yo okugyayo sente zino.
Poza diaper. Ze diaper zenyinza okubiriza Munnayuganda straight up. Kasitoba ng'oli maama nabaddeko emulimira zone ebukoteeyo bamama bangi nnyo bye nasanzaawo abakyala abakozesa poza diaper mwebale kukozesa poza diaper bamama benaguddeko mu mulimira awo
anti bagamba omwana wo zimuyisa bulungi tatoba
munaye akantu kano kaweweelu kayisa empewo bulungi nnyo ate tekawunyisa waliwo diaper ze tubadde tukozesa omwana nazigira naawunya
nga temumanyi bazikoleddewa
so nezibutula abaana this is not happening with poza diaper so mwetanire ebintu bino mwetanire poza diaper kale straight up katusimulule emboozi zetuteeteese wiiki eno ndowooza tuzitandikirewo tetujja balo zaako
tetugenda balo zaako naye of course basuubire bingi mu lugambo lwaleero Kampala anyuma ate Uganda you're not large buli omu waali otunyumira mukola olugambo
weekend yabadde bloody
yes
weekend twagenze ojuwuzika nga olutalo olusituse wakati w'omusajja gwe bayita Shey Umaru
ne OS
omulangira Suuna kati Shey Umaru of course abadde amanyiddwa era erinnya akoze erinnya ddungi nnyo nga Shey omu ku bajja ne bayamba abayimbi ebiseera ebisinga bwe nalaba Spice Dancers concert yavaayo n'amuwa akasente n'akola show twalina Khalifa Aganaga yayina show najja n'amusponsoringa
tudde ku ya Suuna
kakati ne Suuna bw'ategeka show naye najja ne bamuwa sente
bali
abalala tetunabalaba nga batoma naye Yesuuna yavuddeyo n'atoma
n'ayogera bingi awo
obutali bumativu nti Sheikh Umaru ono nti bwakuwa obukadde 10 abukuwera mu kamera wabazijjako n'agamba mbadde ensaaga
gwe tomanyi gwe abantu si bangu nno
of course tunafuna we want to get reactions ez'abayimbi abalala Sheikh Umaru bazzayambo muli Khalifa Aganaga Spice Diana and all of those
tulabyeyo ne gundi ono owa TNS
Rodenwai kabako
omubwati
oyo Rodenwai ayina ensonga ze naye munaye OS awe yavudde entabo yavudde kakati Sheikh Umaru ye wano we yasinzidde n'agamba OS ekisooka OS bukyava mu busiraamu
yasiraana yabyogedde n'amugamba obusiraamu bwali bumuyamba ekyo kimu n'agamba gwe nno oliawo n'abaana bo oluusi tubawa ku buyambi ffe yagedde ebintu bingi n'agamba munange okuza oliawo olina akawoosi oteeka kanta mu mutwe ezo eza white ng'eza tashabi muba mukaddiye mubikanvi mbw ate yamugambako nze Sheikh Umaru walinnya nange nninnyawo amugambye tetuli ku level y'emu
Suuna
nze ndi Sheyi w'obusiraamu toyina kyoli Sheyi no naye alangira
Sheyi wano wasinzidde era n'ateekawo miliyoni aga
3 bweddu
Suuna bw'obanga Sheikh oyina ka vidiyo
ke yatugambye
mbu nakuwa sente n'enzikujjako enkya ku roundabout kaleete Sheyi agenda bba waali
amuwe miliyoni ago
nga nzikujjako obukakafu oba obulina katsooka tufune Sheikh Umaru
katubiwulire
assalamu alaikum warahmatullahi wabarakatuhu nzize okukakasa oba okulaga ekifaananyi ekituufu ku mulabi wa BBS Telefina naddala nga neeyambiza program roundabout kuba nkimanyi nti yeekulembera zonna olwo n'endala ne ziryoka zikola ki zigoberera era amazima mulina gafunira wano ku roundabout omulangira Suuna mukkirize mugaane yavaako bw'abanga yavaako kitegeeza yagwa kati mu kugwa okwo alabika yatabuka omutwe yagwa eddalu toyinza kuva eri omuntu nga waliko omusiraamu n'ova mu busiraamu ate nodda mu bwemoolerako nodda mu busiriwalirako Suuna totumanyiira olw'ensonga kino olwaleero kivuddeyo oba kizze nga bagamba Sheikh Umaru yagamba mulangira Suuna naye Suuna njagala omanye kino kyenkugamba sikikugamba nga nze Sheikh Umaru Suuna kino kyenkugamba tosiriwalira ku busiraamu nkikugamba ng'abasiraamu bonna Suuna yogera amazima bwe wali nga tonnaba kusiramuka n'obeera nga oli eri mu ddiini endala embeera yalimbi ng'olwanya ne music yagaanyi nojja n'osiramuka embeera n'etereeramu bwe waddayo eri n'ogwira ddala ekyo ekigo kyewagwana kuno ogujja tositukange ekyensi yonna ekimanyi Suuna bwe wava eyo n'otandika okubeera nti oweekweka oyimba by'oyimba abantu obalaga nga eyazze eggulo kankujjukizeemu katono Suuna oli kasajja kakadde ekikutintingisa enviiri sigamba nti musono tino simanyi Suuna otintinga enviiri kukweka nvi waliyo nempima namungo nepanga nakombo sekawo malu wayimirira nange nsobola okuyimirirawo Suuna wenyimirira toyinza kuyimirirawo nze ndi sheikh bwe mbeera nga ndi sheikh mu busiraamu ekigambo sheikh oba omuwalimu be basika b'abannabbi
sheikh kikyotegeeza bw'oyogera ku nsonga yogamba nti bwe yava mu busiraamu n'agwa ddala complete land oluso
era bwe yava mu busiraamu kyekigo ekyo kyolaba n'ogujja kyaliko emabegakaawo abadde ajja alwana ne music ng'agaanyi yajja n'antuula mu maaso wano ne muteekako edduwa zange bwe yayisembu obudduwa tebwakola
nawayamu ne maama we n'aŋŋamba nti okujoyininga obusiraamu ebisiraani mwe yabijja
ekyo bwe kiba nga kyayogerwa maama we nga ye yakyogera ekyo nakyo kikyamu ddala maama yaba yeeyisizza nga atali muntu mukulu olw'ensonga mu busiraamu tuyinamu aya ekulaga nti bw'omala okusiramuka bw'ati Suuna yanaaba olunaaba olulaga nti ebisiraani takyabirina bimuvuddeko ate maama ffe abantu Suuna baabadde atambuliramu n'abalala bonna abalaba bakiraba nga Suuna bwe yasiramuka n'atandika okuyimba music yali atandise okuba nga avaayo bwe yava mu busiraamu n'addamu n'agwa
nebazanye Sheikh Omar olw'omutima omugabi n'okwagaliza music industry ogenda maaso abagagga bangi gye muli kano kalowoozo abagagga bangi gye muli mukola ebintu ebirungi n'ebyenjawulo ebirala naye ekintu kye bayita okugaba tekitolina kubeera nga gwe olina nnyo nga gwasinga bonna wabula gobeera mutima Sheikh Omar tukwebaza nnyo omutima bukyanga otandika kumanya ozze ogabira music industry
kituufu ezenda wazimu wate wazimu
anti kati omuntu Allah atukuutira n'atugamba nti omuntu bw'ayavuwala ennyo n'obwongo bwonooneka kati Suuna yayavuwala n'obwongo ne bwonooneka nze namulabyeko katambi ng'agamba mbu yajja mu maaso gange ne muteekako obudduwa obutaakola naye bukyanga ebivulu Suuna byonna byakoze mbuulirayo ekivulu kye yali akoze n'akifunamu ssente nga kino kye namukola kivulu kye yali akoze ne kijjuza nga kino kye namuteekako edduwa olwo obudduwa bwate bwakola kyakubiri yaŋŋambye mbu yakwata akeetaano nakamu n'akateekaawo akeebiri n'ak'omutwalo gy'emitwalo mu Luganda giba 8 kakati mbw ate naŋŋamba ezo miliyoni 3 simanyi 5 mbwate bwe mmaliriza ate n'azikwata n'azizaayo mbu ayina ne vidiyo nga ssente ze muwadde azizaayo njagala Suuna ajjeyo vidiyo eyo nga ssente ze namuwa emiliyoni 3 nga nzizaayo mu kamera mu taawo lyange oba mu kanzu bw'alaga bw'ati ssente ze namuwa nga nzizaayo mu kanzu vidiyo eyo mugambe Suuna tabasiriwalirako njigula miliyoni 3
mbe mubino ebitiro bagaa nti ate simanyi Sheikh Omar wakuwa simanyi adda muki ebbali n'agira no bino biri kwalaali kwanza ndi musajja mulangira era Sheikh Omar tajjakera ku makya yagala ekkola ki kugira basajja balangira kubanga akimanyi bulungi nnyo nti omulangira baba bamuwadde bamuweera ddala
vidiyo eyo wemala n'endaga nga nkutte ssente ze nawa Suuna nga nzizza mu kanzu njigula miliyoni 3 kati bw'ongamba nti nkwetondere kati nga nsinziira ku ddiiru ki twali badde tugamba nti neetondere Suuna ayinamu kaalina naye yagwadde emyaka 5 ali omwavuyiza mu kutiya kaakati avuyiza mu kutiya mba mumwagazaaki bwewawabira Suuna ng'ekyo kye yakoze osobola omuwawaabira nogaba bamuggyeko eggulire eryo bamukwate bamusibe era bajja kukasiba kakutukirekawo naye ne bonowawaabira talina kyagenda vaako
Naga miliyoni 3 ezo.
Miliyoni aga.
Nyingi nno.
Suuna leeta clip. Kati nno naffe tetwagala kati tetukyagala kukola mawulire ga kuwuddisa abantu kusirwalira ku bantu.
Yes.
Suuna tumunoonyeza Suuna okubya akasajja. Akasajja tekalina mutawaana oli Sheyi mulamba. Sheyi tayinza kubanga alimba. Suuna agambye.
Nze ba munange naye
muntu. Ajja wano ku BBS naye ajja na miliyoni aga.
Suuna.
Tagenda na kujja bwereere.
Suuna wange gwe mmanyi.
Bw'omanya ajja na miliyoni 3 oba n'atunda kyapa kya ajja nazo wano. Agenda kulaga
abantu
akatambi ako. Kati no agambye Umar engeri Suna nagenzayo n'obusiraamu
bwavaamu bwadde eno bwaddayo wakolaki
yabuvaamu azze abuvumirira kati amugambye aleeteyo akatambi nga Suna anvumirira obusiraamu okujjako mbu okwagala amawulire Sheikh Umaru Suna kati naye nateeka bwagaleeta akatambi
naye muwaddeyo ekyasatu
milioni
avunuke korona kuba tuyisiza bubi fenna
kakati era Suna abisa bibeere ku round about
otyo
kati ekya Sheikh Umaru omulangira Suna tetugenda otegekawo n'emiggo
n'ettebo yaabwe
alimba nadda
buli omu kwateeka akatambi.
But anyway, on a serious note, so this is what Suna has reacted on this. Asubiza milioni asatu incha. Filimu incha.
Suna wafumu bwati. Katubirabe.
Feke Umaru. Mundi gwe nasoko mwesenkana mu nsera sedanga mulaba. Okimanyi bulungi bakwacha aliwo togenda mwabya naye okimanyi teyajja ku show, teyagula tickets n'obusente bwe yatuwa ku meza yabujjawo ng'olaba. Naye bwe
naziraba esanda zazagendako ku meza.
Feke Umaru ajene milioni yaga. Nange ntaddewo milioni yaga nga bwazitaddewo bwabanga zeyayogedde ajene kiripu gye gyalina nga nvumirira obusiraamu kwe yasinzira okutandika okunvuma ajje nayo bagizannye wali nga nvuma obusiraamu bw'aba tagirina asatu ngalya nange ngenda kuleeta kiripu nga mpa ssente ate ng'azinzijjako nga mpa emitwalo egi oyo twagenda tumumanyi lwakubanza ekyamusaasidde na busaasizi twagenda tukimanyi nti ajja tufera
wangi
tulina kiripu eri mu ssimu ne kiripu yakwatibwa kamera zaatalaba okitegeera okuba kati kasajja kattu kaako kamusujja nkattira obwendere kakyeyiya akasajja kattu so nze bwaba enkya Roni essimu yange ogiina bwe ngamba kimu ti akasente kategekese Sheikh Umaru tugende mu ki tugende ku TV twagala
kiripu sozirina
anti kugambye nti bwe tunadda nti ate kiripu ziteekeyo bitebijja kukola tugenda kubeera mu round about mwennyini bazanye yange nga nvuma obusiraamu bazanye ya Sheikh Umaru nga atufera ssente kyenkuga enkya anti ali ready agambye nti ali ready asatu tazitulaga nazitwa kuba nkimanyi tazirina naye tazitulaga kiri oke ajje nazo nakakiripu nze nga nvuma obusiraamu akaleete nange ngenda kukwata akakiripu kange nga mpa atulimba obusente n'amaloboozi mwegali bulungi kuba twajja n'ebyuma ebikwatira ddala bulungi yamanyi ndi mu kusaaga
bakusaaga Suna akola ki
Suna alisiya
ojja otya omuntu n'oleeta obukwata amaloboozi wali ozize kutugumbula muno obukwata amaloboozi abulina
ekitegeeza Suna yali abisuubira bayinza
munnanga ayinza bba yabisuubira katubirinde byonna tujjabiraba yes of course
muliko omutuufu n'omulamu and this is the
ate kuliko alimba n'atalimba
exactly roundabout is still here mukama agenda tugabira obulamu enkya
ate era mukama n'ayamba
enkya Suna agenda beera wano Sheikh ali wano buli omu alina busente bwe wano buli omu aleeta vidiyo ye sente nazikuwa gwe wazitwala tugenda kwetoloola mu small time tukole ku sente z'abakama baffe naye bwe tudda mega sure ina mukama n'ayamba omuzadde funa kapoza diaper and of course get yourself an account with Centenary Bank osobola okozesa enkola yaffe eya Sente Express small time tukomawo